In the second part of the lecture, I would like to explain the user adoption barrier at various IoT application level. Okay, I have taken different application levels according to the and explained the parameters which we have discussed in the different domains. Firstly, I have taken the infrastructural domain, in which I have taken the example of smart city. The IoT technology provides, in a way, an infrastructure for object to be connected, creating a network that resembles a smart environment. Such a network may represent buildings, waste management system, energy grids, or whole cities. The role of the individual varies in these networks. They either act as a service and user who also own an IoT device, such as smart meters, or as one who is affected by IoT device indirectly, such as citizen benefit from the CO emission monitoring using sensors. This limited and often indirect and hidden interaction with IoT make the end user adoption challenges in a different way as compared to the other domains. At best, end users are able to assess the influence of IoT on their experience, that is city life. Thus, the adoption barrier are most experiential. Previous studies have shown that the individual comprehension of the relative advantages of smart city technology, such as realizing the impact of IoT on a different city aspect, is a key factor in adopting the related services. An important precursor to assessing this impact is to be aware about the initiatives and services being offered in one city. Accordingly, if the cities and service providers are not transparent with the service and their availability, citizens tend to be reluctant to the engaged. Being aware about the smart city technology, end user can gauge if the technology is feasible to adopt, if it is cost effective, and if it is compatible with their lifestyle. IoT is regarded to be compatible in the case it requires no to minimal change from the end user. For example, learning new skills. Soft skills and ICT skills are required by the citizen to interact with the service, make it one factor hindering the adoption of smart city. Next is complexity is also relevant here since various group of end users are engaged in the implementation process. Their participation could be affected if they experience difficulties, especially if they compare it to the traditional service or other more mature IoT services. In this regard, usability, ease of use, and US aspects are important factors to minimize the complexity. In addition, the security of IoT technology represent a main concern for end user, comprised of vulnerability, third-party access to the device, and availability of the services, particularly in the case of disaster, incident management, and emergency response. The level of device security indicate that malevolent acts by the hacker or foreign governments are not successful. For example, penetrating devices and using the infrastructure as a weapon of mass surveillance. This relates to the next main concern over IoT in smart cities, that is privacy. Main researchers and practitioners noted privacy as a key constraint increasing the adoption of an innovation. Factors related to privacy include awareness related to the collection of data and use of services, especially big data services, where the concern of personal data protection is significant. Privacy has implications on two other important adoption barriers: service quality and trust. It is suggested in the literature that a poor quality of smart city infrastructure limits the added value and perception of the smart city services. Citizen trust in the service provided within the IoT domain is another influencing factor to handle the risk, threats, and opportunities. Trust is both related to the information handling practices of the IoT manufacturer as well as those of service providers. Compared to the security and privacy, ethical concerns are found to have a minimal effect on the smart cities service adoption. So we can see that whatever the adoption barrier concern we have discussed in the previous lecture are all implicable in this infrastructural domain where I am talking about the smart city. Okay, now similarly we will go for the individual domain. I am going and the individual domain we very much concerned about the wearables, especially smart glasses, smart watches and various smart things जो हम लोग usually wear. Now, let us see in this domain. Factor influencing the adoption of innovation with a wearable sensor can be broadly categorized into general, physical, and software characteristics. The general factors presented include the high price associated with the emerging technology, culture and the gender for specific wearables, social influences, and personal preferences. Physical design and characteristics could also influence the adoption and diffusion of the wearables. Another necessary physical characteristic is the device mobility, that is, not being heavy. User need to have access to the information anywhere with the ability to move to difficult location and use their device in transit. In the same way, comfort is an important requirement for adoption, where the user does not feel extra burden when wearing the device. Uncomfortable wearable can inflict health risks on the user such as bruise, burn marks and rashes. One study confirmed that there is a negative impact of perceived health risk on the user behavioral intention to use smart glass due to health concern related to the radiation emitted very close to the brain. This was one of the study. Additionally, the physical and aesthetic design aspect of the wearable device can create a form of a stigma, in a sense that the user might feel ashamed because others interpret the usage of the device as a sign of weakness or illness, resulting in the worsened social image. Moreover, the user environmental situation vary greatly and the device may be exposed to extreme temperature, shocks or contacts with water and dust. Thus the rigidness of the device play an important role to make sure that the device can operate in the normal condition and even sometimes in the harsh conditions. Next, that is one of the most general part, that is battery life, as a key challenge in a wearable due to their design restriction. They are movable, sometimes small and thin. It leaves little space, compromising the battery capacity. Last on the physical characteristics, sensory errors represented by the inaccurate and missing measurements is another factor that could have a negative impact on the user adoption. Characteristics related to the software and the digital service associated with the device greatly impact the adoption of the wearables. User perceived value of the innovation in the real world is one of the prominent factors that is well understood in the domain of wearables. Users should be able to clearly realize the advantage of wearable compared to the other device or service delivered the same function. The perceived value is connected to the ease of use and the functional elements. A well-designed interface promotes the ease of use, and user interface for wearable is a vital design factor to achieve greater user experience. User interface are related to presentation of useful, accurate, and valid information to the user. Simultaneously, the interface design should avoid overburdening the user's cognitive functions by, for instance, using complicated language or lack of context. This adoption barrier could be elevated with the design of a user-friendly interface. Moreover, the functional elements such as integration with other devices, portability of the data, and supporting softwares are relevant to the service of the wearables. Similarly to the infrastructure domain, data collected via wearables are subject to privacy, security risks, especially in the field of health wearable owing to the sensitivity of the collected data. Usage ban has been proposed for some wearables, for example, smart glasses in some places, such as in movie theaters, to avoid the movie piracy, or changing room to avoid illegal filming. These are some reasons that user could not wear the device all time, influencing their adoptions. Okay, these are the in this scenario we can also see that what are the barriers. Here barriers are little bit different compared to the infrastructure one. Now let us see the other example. Now I'm considering the all inclusive domain. I'm taking the example of autonomous driving. Now, the current disclosure on autonomous driving suggests that trust remains to be the number one barrier to its acceptance, adoption, and continued use. And user trustworthiness toward the autonomous vehicle are related to the different characteristics of an autonomous vehicle, such as deceleration, acceleration, different types of turns, T-junction, U-turns, and steering. Trust issues are typically associated with the emergent technologies, particularly when it represents a big leap, leaving prospective users with a little control over, for example, steering, throttle, or braking without their direct input. Because the end user is not directly controlling the car, therefore there is a trust issue whether it will work or not. Individual belief and general attitude toward autonomous driving can also shape their decision about whether to use an autonomous vehicle or not. Data and information security aspect affect these negative attitudes, manifesting in fear that an autonomous vehicle, just like other IoT device, will not be entirely secure and that data may be misused. Infringement and personal data misuse are main consequences of the user fear. Other subjective and personal preferences increase the adoption barrier toward the autonomous vehicle when compared with personal and traditional cars, such as the hedonic value of the driving experience, that is, fun of driving, or you can say control and the sense of freedom. These all are absent in the autonomous driving. So this is again a barrier, adoption barrier. The lack of awareness in its general term includes the lack of knowledge on how litigation and liability works with the autonomous vehicle. This is another issue. For example, the public have their doubts and uncertainty, rightly so, regarding regulatory agencies, insurance and the liability issue arising, including the persuading insurance provider that the technology will work properly in the other driving environment or not. Concern involve around the, for example, who is responsible in the case of an accident and how fully autonomous vehicle user might be held accountable. Who will be responsible in that case? The driver, the technology provider, or the service provider? So this is again a concern. How the insurance agency will give the insurance for this type of autonomous driving system. Okay, the next is total cost of ownership or service is also still unclear in this domain, influencing the adoption. Costs associated with the self-driving cars are related to the ownership, maintenance, fuel and tolls. Well, Google is tackling this issue currently by deploying the various machine learning models for cost learning and estimation. So now again in this autonomous driving system, you can see the lack of knowledge or interoperability, and here the issue are much more social and economical. Now, in the organizational domain, I have taken the example of a smart agriculture and farming. On the organizational level, IoT is used to manage the resources across various lines or vertical within the organization as well as across the food value chain. Now, in smart agriculture, sensors are used for verticals such as water management, crop management, soil moisture, pH measurement, while smart farming, livestock management represent a key vertical. While each of these verticals has its specific adoption barriers, most barriers are cross-cutting the whole industry. Trusting the technology provider is also the main influencing factor on adoption, mediated by the perceived value of the IoT solution and perceived risk associated with it. They further define the perceived value into economic, environmental, and epistemic value. In addition to trusting technology provider, trusting supply chain partners using a specific IoT technology is a determinant factor in the process of adoption. Next is a lack of technical knowledge among the farmer is regarded as an important factor in challenge adoption. This factor becomes more challenging in rural areas within the developing countries where there is a lack of education and awareness of the technology. A lack of literacy add an additional complexity to use an IoT technology in farming. On the other hand, if I come to the industrial part, the employee resistance to new technology does not influence adoption. Normally, it's perseverance that employee resists to the new technology. That is not the main adoption problem. Instead, the size of the organization and the complexity of the technology are the most determinant factor in the adoption. Specific technical characteristics also influence the adoption of IoT in agriculture and farming. For instance, the common centralized architecture of IoT platform creates a bottleneck causing the delay in the communication. While this may not be critical in most of the applications, some applications require real-time data collection and analysis that may be hindered by such bottlenecks. Centralized architecture are also the main barrier towards scaling. Others suggested that explicitly accounting for weather-related powers and internet outage in IoT platform design lower adoption barriers and prolonged deployment periods. On the hardware side, battery capacity, lifetime, and sensor storage capacity are among the challenges affecting adoption. The cost of this unit and overall IoT service are also influential. There are also the infrastructural factors influencing the adoption. Technical infrastructure factors such as the stability of internet connection in the agriculture, rural and farming areas. Sorry for this 62. And the political infrastructure factors such as governmental support for the IoT projects. So these two are the main infrastructural factors influencing. One is the deployment of internet in the rural areas, and finally the government support for these IoT projects. So finally, like any industry, agriculture and farming are subject to external pressures, more specifically dietary trends at the consumer, and have major impact on how the industry operates and the technology adoption decisions. So I'm coming to the conclusion. We have seen the various adoption barrier theories, not various, common adoption barrier theory. On that basis, we have assigned some barriers, assigned, not saying assigned, but you can say that we have come to some of the adoption barriers due to which we can't implement IoT so much. We have seen all these parameters in the different domains uh, uh, by seeing some examples. There are many more examples which cannot be covered, but still I've tried to explore the adoption barriers points. Now, finally, I conclude that today billions of Internet of Things devices are already connected to the Internet and transforming our lives. However, the recent confluence of key technology and market trend is ushering in a new reality for the Internet of Things, with some seeing to on the horizon of fully interconnected smart world with the relationship between object and people and object and their environment becoming more tightly intertwined. While the potential benefits are significant, there are serious challenges that must be addressed so that we can maximize the benefit while reducing the risk, particularly in the area of which we have already discussed in elaboratively: security, privacy, interoperability and standards, legal, regulatory and right issues, and the inclusion of emerging economies. Finally, I can say that the Internet of Things involves a complex and evolving set of technology, social, and policy consideration which require input from a diverse set of stakeholders. Finding solutions will thus require informed, engaged dialogues and collaboration across a range of stakeholders to plot the most effective way forward. Thanks. Thank you very much.